Hello, everybody. This is Pete from PA Labs, and our application has taken another rewrite. I've added a lot of niceties, but the big change was a yet another uh, tile set rewrite. And basically, I eliminated these two tables and the collections and records and all of that and consolidated all the images for an individual tile to be a sprite sheet. Okay. And the new structure is like this with a sprite sheet inside here. And each record here translates to a single tile here. Now, what defines a single tile? Well, for the vast majority of these, it defines this as a single tile, or this brick wall as a single tile. On some of the others, it may be a single square, 48 by 48. Whatever a single tile is off these tile sheets, it has a record and it has a sprite sheet. Okay. Now, in saying that, I now have redefined this single tile because of once I started getting into uh, the overlapping of one box on top of a same kind of box, and we wanted to merge them, then that's where this upper, what I was calling tile 2, because I had no idea what really it was. This is tile 2, or was, and tile 2 is no longer tile 2. Tile 2 now encompasses 6 tiles. I take off a 16 by 16 square here. I take off a 16 by 16 square there, and a 16 by 16 square here and here. Then I actually say, okay, the upper right to lower left is one tile. The upper left to lower right is one tile. All right. Now, with that exploding the number of tiles, the image tile type, now this is a type table that I have in the system. Its enumeration begins at 0. So this plays very nicely into reading the sprite sheet, okay? Because I can use the name ImageType image1, and that identifies the X coordinate of my sprite sheet. So the sprite sheet itself is 4 rows of 17 tiles. These are the 17 tiles. And each of these tiles is saved at 32 by 32. All right. So to get the X coordinate across those 17 tiles, I just use his image type of the actual tile here and multiply by 32. Now, you could be asking, why are there 4 rows? There's only one tile. Well, there's only one tile if I'm looking at this one. But if I come over here, this one tile has 3 images, as well as this. Matter of fact, all those single 4 tiles that make up this column have 3 actual images. Each of these, this would be tile, or the sprite sheet row 0, 1, and 2. Okay, so that handles 3 of the 4. And now let's go ahead and jump into the what I call the vortex, okay? And the reason I call it the vortex is I was looking at one where it was a tornado or a whirlpool. And so you have tile 1 and tile 2, but then the 4 down here make up, well, what would be the 9 on this tile, are the 4 images that are the spinning aspect of this tile, or the waterfall aspect of the tile. So we have, to break that tile up, we have four identical, not identical, but four images of vortex, plus we have tile one. So that the tile one will always be in the position 1, 0, 0 for 32 by 32. These remaining four that make this tile up will be in the vortex column, rows 0, 1, 2, and 3. Okay, so not a whole lot of tile used on that sprite sheet, but that's perfectly okay. The math all works beautifully. So that was the big change into this release. Now I want to find the, I want to actually walk through how the tiles are broken up for you, because I think that this is an important thing for y'all to know how to do, especially if you're kind of tracking all of this and wanting to do it yourself and see how it is that I went about it. You may come up with a better idea. Entirely possible. As I've always said in these videos, there are always many solutions to a problem. The trick is finding out one that is acceptable for your requirements. So when you select your tile sheet to import, all the tile sheets of that type, you select an A1. So I'm going to take the name and load the A's, the B's, the C's, the D's, the E's, all of them for that one sprite sheet. Okay. Now, that is done in one process for the tile importing. And basically, he breaks it up by sheet and then calls the sheet the appropriate sheet load, which is here. Now, this is where a lot of the validation is. It says, okay, when you load an A1, that sheet better be this size. Otherwise, there's an error involved here. Somehow we got the wrong sheet lined up. And then if it's an A1, then it's got that, oh my God, weirdo counting for matching the name to the actual tile itself. So if the tile sheet that we're loading is the A1, then in order to match the names in the A1.text to the actual tile, it's an insane counting thing as to what tile matches to what name. So this isn't my finest hour for code. I did them one at a time. Okay, so if we actually look at this particular tile, it's, this guy's 1, this guy's 2, this is 3, 4, 5, 6, 7, 8, or something like that. I figured it all out on one of them, and I use the same pattern. So there's 16 different tiles here on this one sheet, and it's an insane order structure. It's kind of crazy. So that is what all of this is. You got 16 individual blocks of code that read that tile. But the gist is, he reads the tile and then he says, okay, this is a 3. All right, this is one of those moving tile guys that has the 3 images, which there's these 4 and then there's these 4. And so I have up here, he'll call this A1 tiles function and pass all 3 tiles in. That function's job is to create the sprite sheet for all of that. When he's messing with a vortex, it's his job it's this guy's job to identify what a vortex is. So when it's a vortex, he calls the 6 tile guy. That's the A1 and 2, and then the 4 that make up the spinny thing. Okay. And then we have an A standard. Now, an A standard, you may be asking, what on earth is an A standard? Well, this single tile here is an A standard. It's got the two top tiles and then the 9 that make up the grid at the bottom, okay? This guy here is a standard tile. If you looked at these 3s as individual tiles, they could be standard tiles. But when you come over here to like let's come to this guy. This guy he's got a standard tile on top. Okay. This is a standard tile on top, but this is a different tile on the bottom, a different set of 4 down here. Yipes. The underneath. So he's read differently as well. So, and then at the very bottom, we have the 48. Okay, and that's just a simple 48 by 48 grid on the image. So this tile here, whoops, not that one. This sheet, please, Pete, you can get out of the way. This one has a standard tile on top, and then this image is broken up as a standard 48 by 48, if I can get it to be still there. So he's broken up as a 48 by 48. This guy's broken up as a standard, okay? Now, those functions, if I break into the standard, and this is where that using the ImageType is just a beauty. So this function gets passed. So here's my tile sheet handle for where this sprite sheet's going to be generated. Here's the image ID. So this is the actual image of the tile that I'm breaking up this way. And so we grab the top left, 48 by 48, and that's our image 1. So we can write our image 1 in. Okay, then we start our sprite sheet. Okay, so our sprite sheet is made up of 17 4 rows, and everything's a 32 by 32. So we can go ahead and draw in our grabbed image 1 at 0, 0 and automatically size him to 32 by 32. Now what we're doing is those connector little tits that are 16 by 16 in the upper right, upper left, lower right, and lower left. These are a very special animal because the tile itself, the 32 by 32, needs to be the center tile. So what I'm doing is I go get the image cell of the center, the mid-center of the 9 by 9 grid, and I create the tile using that. Okay, so we draw that in as the upper left tile. Okay, so that gives me my background. The whole thing is now water, or it's a hole, or it's lava, or whatever the heck it is. Then I grab that 16 by 16 little nodule tit kind of thing and paste that in where he belongs in the upper right, left, or what have you. So it takes 2 copy maneuvers to get each of those out, and it takes 3 maneuvers to get the diagonals, the upper right, lower left, lower right, upper left. And so we go through all of those, and you can see how I'm leveraging using the name as a multiplier to find where he belongs on the grid. Okay. And then we come down to the 9 by 9 grid. That's very simple. We just walk our way through as a 32 by 32 and just put them where they belong. So that is the new tile structure. So I'm going to probably say this is the end of video 1.